In this section, we're going to discuss the basics of statistics. All right, so we're going to start out with uh, just two broad types of statistics. You have what's called descriptive statistics, which is about collecting data, sorting it, organizing it, summarizing it, and displaying it. All right, so and typically you'll do that at it's typically a small operation, so to speak. Um, and then you have what's called inferential statistics, which is using descriptive statistics to estimate what they call population parameters based on sample data. So what'll happen is just think about you're trying to conduct a study, uh, which is going to cost you time, money, human resources, equipment, so on and so forth. So instead of you asking everybody, you try to get a solid sample, and we'll discuss that in a minute. And then what you do is you use statistical tests to make inferences or educated guesses about the population based on the sample. Quick definition. We're going to start out with in statistics you have what's called a population. All right, and the population is just simply the group or collection of objects that you're studying. All right, so then you have what's called a parameter. A parameter is a value that's calculated using all the data from a population. Now, if you think about that, let's think about the size or the population of the United States of America. We're probably at 320 million people. All right, that's the population. The parameter would be something like, what's the average age of a United States citizen? All right, that's the parameter. That's the value or the numerical value that you're trying to calculate. All right, in most cases, it's not economical to study an entire population. When you do something like that, that's called a census. When you study the entire population, it's called a census. All right, but again, in most cases, we won't study an entire population. We'll do something that's called we'll take what's called a sample, which is a subset. All right, which is just simply means it's a smaller group of the population. Now you want it to be representative, so what they call the gold standard, and I'll get to that in a minute. In terms of sampling techniques, it's called a simple random sample. All right, where everybody has the same opportunity to be selected for the sample, regardless of the subgroup or subgroups that they belong to. All right, so you've got this big population, and let me draw it so you could visualize it. All right, so you've got a population. All right, that's the group we want to study, but it can take a whole lot of time and a whole lot of money to study a population. All right, so typically when you do a study, you grab a sample, right, from the population. All right, so your bigger group, population, your smaller group, sample. All right, now when you're talking about population, you're talking about parameters. All right, when you're talking about some value related to a sample, all right, we call that a statistic. All right, so remember, that's how you relate it. Population is your big group, samples your smaller group, parameter applies to the population, a statistic applies to the sample. And as you go along in your statistics classes, you'll have what's called inferential statistics, which simply means if you sample correctly,
you can make inferences about your population based upon your sample. But again, that's for a course beyond this one. So for our purposes, I just want you to remember population is your larger group, samples your smaller group. All right, so now let's look at an example. And we're going to identify a couple different things. The city of Raleigh has 8,700 registered voters. There are two candidates for city council in an upcoming election, Brown and Feliz. The day before the election, a telephone poll of 600 randomly selected volunteers was conducted. 197 said they vote for Brown, 388 said they vote for Feliz, and 15 were undecided. So now we've got four things we want to identify: the population, the sample statistics, and then we're going to apply those to answer question for the number and percentage of voters expected to vote for Brown, Feliz, and who are undecided. We're going to round to the nearest percent, or the percent to the nearest tenth, and people to the nearest person. All right, so let's start out with population. All right, we know for a fact we've got 8,700 registered voters in the city of Raleigh. So you've got to be very careful about defining your population. 8,700 registered voters in Raleigh. Now, we don't know if that's Raleigh, North Carolina, but we're just going to say in Raleigh for this particular example. All right, the sample. Sample in this case were the 600 voters who were polled via telephone. All right, the sample statistic. All right, you've got a couple different statistics. You've got 197 voters for Brown, you have, now you can convert these if you want. So let's go ahead and convert them to percentages. So 197, and again we're going applications a percent. 197 divided by 600, we want to convert to a percent. All right, so 32.8% will vote for Brown. Then you do the same thing, 388 out of 600. So we're going to go to the nearest decimal place. That's 64.7% will vote for Feliz. And then we've got 15 out of 600 are undecided, which is, in this case now, it says we're going to go to the nearest tenth, all right? So 2.5% are undecided. All right, and I'm gonna write up at the top of the slide how I did that. 197 out of 600. That was Brown. 388 out of 600. It's Feliz. then 15 out of 600 were undecided. All right, so we got the number and percentage of voters expected to vote for Brown, for Lees, and who are undecided. All right, now those are statistics for 3. All right, 4, all you're gonna do is take these percentages, and we're gonna say 32.8% times the 8,700 voters. And we get 2,854 voters for Brown. All right, then we go to Feliz. Feliz has, based on our sample, if we've done this right, Feliz should get 64.7% of the voters. So we're gonna go 64.7% times 8,700, and we get 5,629. I'm gonna say that's how many voters will vote for Feliz. And then our undecided, we had 2.5% times 8,700, so 218 is undecided. All right, and that's how we apply a sample statistic to the population and make an estimate. All right, so then you've got what's called, you've got different types of data. Now you've got 2 data types. You've got categorical or qualitative, all right? And these simply are words or numbers that describe an object, all right? So it's descriptive. That's probably a better way to say it, that categorical or qualitative data, they describe. Quantitative data are responses in numerical in nature, and you can calculate it. So you can make some sort of calculation, average. You can find the difference or the range, but you can perform some kind of arithmetic calculation with quantitative data. All right, so a couple examples. All right, so zip code. Now, zip code is a 5-digit number, but it has no meaning. There's no such thing as an average zip code. So a zip code is used to describe a geographical location. So this is categorical, or you can call it qualitative, all right? Eye color, again, eye color, there's no average eye color, right? So it describes, so it's a categorical, or you can call it qualitative data. All right, daily high temperature. All right, you can have an average high, so that's quantitative. And then annual income, again, you can perform some type of calculation. So that's quantitative. All right, so remember, categorical or qualitative data describe. Quantitative data, you can perform some kind of calculation. All right, now we've got what's called sampling techniques. Basically, a sampling method is biased if every member of the population doesn't have equal likelihood of being in the sample. So, for instance, if I've got 5 children and I'm taking them all on a trip, or I'll say I'm taking them all on a trip, but then I leave one out, right? Or I'll say I'm taking 3 out of the 5 on the trip, and then I just tell the oldest 2 they can't go, then that's pretty much I'm being biased, okay? So think favoritism when you see the word bias. All right, so then you've got different types of sampling. You've got a random sample. Every member in the population has an equal probability of being chosen. You have a simple random sample. Now it's a special type of random sample. Every member of the population and any group has an equal probability of being chosen. So groups and individuals have the same probability. Stratified, you're taking groups, subgroups within the population. So that's a stratified sample. You've got a quota, which means you might have so many subgroups, but you want so many people out of each subgroup. That's a quota. So let's say I've got males and females, and I want 25 of each. My quota is 25 males, 25 females, okay? So you keep sampling until you reach that quota. A cluster is where you're taking samples from like sets of subgroups. All right, systematic sample, you take let's say every 5th person. So you've got, and you don't deviate from that system. So if I'm taking every 5th person, that's what I do. I don't say, well, I'm gonna take the 5th, the 5th, the 5th, the 5th, and the 4th. That's not systematic. Systematic means you're gonna be consistent with your sampling technique. All right. Convenient sampling, you sample the group that's most convenient for you. So let's real life example. You have a group of friends and you've got this research question, all right, and you're being kind of lazy. You don't want to put in a lot of work in terms of creating a simple random sample. So you just ask your friends, right? Because that's easy. It's what's available to you. It doesn't require a lot of effort to kind of go out and get your sample because it's right there. And then voluntary response, we all get that. Anytime we go to the store, and they typically on the receipt, there's always the complete this survey, okay? That's voluntary response. Either it's on the consumer or the end user to decide or to opt in for the survey. So that's what it is. It's voluntary response. All right, then we got a couple questions here. We want to identify the type of sample. So this first one says, a sample was selected to contain 25 men, 35 women. All right, now I've got 2 subgroups. I've got men and I've got women. All right, so that's stratified. Okay. All right. Next question. Viewers of a new show are asked to vote on the show's website. Now it's up to them to vote, so it's a voluntary response. All right, now we have every 4th person in the class was selected. So now notice, I've got 4th person, and it's every 4th person. All right, so this is a systematic sample. All right, the next one, the website randomly sends a satisfaction survey to 50 of its users. Okay, now it's a random sample, and we're going to assume that every subgroup has the same opportunity. So we're going to go with simple random sample. All right, and then this next one, to survey voters in the town, a polling company randomly selects 10 city blocks and interviews everyone who lives in those blocks. Okay, so now you've got 10 blocks, and then you're interviewing everybody in it. That's clustered because you separated your population into clusters or these groups. All right, and then the final point. And again, as you go along and you become a researcher, you're gonna have different types of studies. You've got what's called an observational study, and basically what you do, you don't make any intervention. You just observe and you take measurements. You don't really interact with your sample or your population. Okay, you just collect data. That's called an observational study. Then you have what's called an experiment. All right, and the difference is the intervention or the treatment. That's what they would call it as well. Is you have this typically this sample that you're studying, and then you intervene in some way, and then you measure what's happening versus a control group who doesn't get the intervention. That's called an experiment. All right, and so that's an overview of the basics of statistics.